We're going to talk about Chrysalis. The Chrysalis project is a stepping stone that will help IOTA remove the coordinator, improve user experience, and make the IOTA network more efficient overall. First, let's talk about the removal of the WINTERNITZ one-time signature scheme. For starters, you should know what a signature scheme is. If you don't, it's simple. A digital signature is a mathematical scheme for verifying the authenticity of digital messages or documents. A digital signature allows for non-repudiation. This means the person who sent the funds was required to hold the private key in order to do so, thus ensuring the legitimacy of the transaction. Leading up to this point, IOTA has used the WINTERNITZ one-time signature scheme. This signature method is extremely secure. However, the fallback of this scheme is that you can only use it once, hence the name. This is a major headache, as you have to constantly make new IOTA addresses to send and receive IOTA. This is why in the coming Chrysalis update, IOTA will switch to the Edwards Curve Digital Signature Algorithm, or EDSA for short. EDSA is a well-trusted signature scheme that Bitcoin and Ethereum have relied safely on for years. The best part? It allows for static, reusable addresses, which will help tremendously to improve user and even developer experience. Now, we'll briefly cover the switch from the current ternary bundle construct to the simpler atomic binary transactions. Originally, it was thought that ternary computations were more efficient than binary ones. While this might still be true, it seems to only be true with specialized ternary processors, ones that don't exist in the market today. While ternary still might be the future of processors, today we only have binary-based ones. This means the move to binary atomic transactions will reduce validation requirements, reduce network overhead, and improve spam protection. Implementing binary atomic transactions will also ease implementation efforts and allow for better maintainability of IOTA's core node software. This should improve network performance all around. Lastly, let's talk about the new UTXO model used for balance tracking. Unspent transaction output, UTXO, simply means that instead of keeping track of only the balances, you also keep track of where the balances came from and where they go when they are spent. Currently, IOTA uses a balance model that maps every address to the associated balance. This method limits how efficiently IOTA can deal with conflicts, like double spend attacks. Currently, this problem is dealt with by using the heaviest subtangle wins, kinda like how Bitcoin uses the longest chain wins. However, with coordicide coming and a completely new consensus model, it's important to identify these problems as fast as possible. A new UTXO model that carries a little more detail will help tremendously. Instead of just showing the balances, it will detail the transactions that took place, where they came from, and where they went. A downside of this is that it will add to the transaction size. But other than that, the benefits are far superior. Faster and more exact conflict handling, less overhead for voting-based consensus, support for colored coins, and it makes it impossible to steal funds by reattaching old transactions. Our video today only scratched the surface of Chrysalis. If you'd like to learn more, please follow the links in the description. As always, from everyone at Everything Tangle, thanks for watching.